Hello everyone, and welcome to our latest PV Tech Talk product series webinar. This is Mark Osborne. I'm the Senior News Editor at PV Tech and the moderator for this webinar. The focus of today's Tech Talk is a brand new Jinlong Solis three-phase hybrid PV inverter, which is actually designed to offer key energy storage solutions for the residential and small and industrial PV markets. Joining us today will be two presenters from Solis, Sandy Woodward, Sales Director Europe, and Paul Carpenter, Technical Manager at Solis, also for Europe. A quick reminder before we start that we will have time for a short Q&A session, and then please feel free to post questions throughout this webinar, and we'll also have Solis staff on the webinar to help answer any questions you may have. Okay, guys, so if you're ready, we have a lot of great info to get through today. Sandy, the floor is yours. Thank you.
Great, thanks Mark, and thanks for having us on this session today. I thought before we get into the product side of things itself, I thought I'd just give a quick update on the company. We've just happy to finish our first half of the year, and first half results are up. I think most importantly, the company was publicly listed last year, and that makes us one of the only string inverter manufacturers in the world publicly listed. It was listed on the Shenzhen Stock Exchange last March. This has given us great impetus and ability to now grow. The photo on the left is a new factory we've just broken ground on in Ningbo, China, just a couple of months ago. We're hoping to bring that 20 gigawatt facility online for mid 2021. So as the graph on the right shows, half one results versus half one 2019 is nicely up, and across the board investment in the business is growing. Teams are growing around the world, and the future's looking bright. So if we look at why we're all here today, and the kickoff here is for the new three-phase hybrid inverter. We've had a single phase offering in the hybrid world for the last few years, and we've taken a lot of that knowledge and learning from our first foray into storage a couple of years ago on a single phase platform, and now are delivering it into this first of our three-phase hybrid storage solutions. So we're kicking off this range with a 5, 6, 8, and 10 kilowatt hybrid inverter, and this is just the beginning. We'll see ever increasing sizes to match the portfolio of inverters you expect to see from us today. This first solution is a 400 volt battery solution. Our launch battery is Parlontech's new 400 volt unit. We've always had compatibility with LG Chem, BYD, amongst others, and the approval process and certification from both sides is underway with both of them on some of their new upcoming platforms. So what this new three-phase solution gives is a cost competitive product that Solis installers, customers that are already used to today can rely on, and hopefully open up opportunities for new installations and solve people's problems. So if we look at what we're going to go through today, it is how we can take this new product and how it can help resolve customer issues, installer issues. They may not even know they're having them, but it's how we can use this storage solution to help situations. So I think one of the obvious or maybe obvious benefits of putting storage in a property would be to hopefully manage a demand mismatch between your solar generation and your on-site generation. This graph is something we're all pretty familiar with in this industry, but it's really how we can utilize our new three-phase solution to improve this. So hopefully Paul can give us a bit of a run through here on how we can do that.
Excellent. Thank you very much, Sandy. So I'm just going to talk to you about this profile and introduce how our systems are generally not satisfying this energy mismatch at the moment. If we look at the trace, the gray trace here for loads, showing us in the early morning, we wake up in the mornings and turn on our kettles and hot plates to cook our foods and so forth and get ready for the day. This is when we're pulling most of our loads from the grid and paying the most for electricity, as you can see here, where it goes red. At this time, the sun hasn't risen properly or at all, and we have to pull that all from the grid. So very little of your PV energy is actually canceling out with that load at this time. And then the next stage of the problem is in the middle of the day, when we have all our PV kind of peaking off, and this is when we're at work and the kids are at school and the loads are very low. And what happens when this is occurring is most of your PV generation has actually been exported out to the grid. In some markets, we get paid for that, but in most markets, relative to that amount we get paid for this export, it's very low relative to the amount that we pay for the electricity when we're using it. And this factor really makes sense for a lot of energy sectors around the world. Even if your energy market doesn't apply this model where you pay more for import than export, I suspect in the future it will change, and this will become a thing of the future where you pay more for import than export. And then carrying on with this example, the same phenomenon happens at the end of the day where the loads peak up and your solar energy is not coming in to cancel it out. The goal at the end of the day to satisfy this problem would be to get every watt of your precious solar generation to cancel out every watt of consumption that you have. And the only real way that I can see this being solved is using storage. So looking at this example, we have a lot of, the sun is shining, it's the middle of the day. We have a lot of solar energy coming in. And if this was a normal PV inverter, not a Solis hybrid inverter, the energy would go through to your loads, very easily done. This is nothing special. And the remainder of that energy will go out into the grid and leak out into the grid. And as I highlighted previously, this is the problem. But with your Solis hybrid inverter, with its special meter that it has connected to it, it's seeing this grid power, and it sees the leakage of power going into the grid, communicates this very quickly through to the Solis hybrid. The Solis hybrid makes the clever decision to charge the batteries, and in charging the batteries, it reduces the export. So that export goes through to zero. What's good to note here is that this energy, this PV energy that we're getting from the sun, is going directly into your batteries. With other topologies like this, we had a lot of thought about what topology we're going to use inside this inverter. And with this topology, it was clear cut that it was the most efficient. It's going straight into your batteries almost through very little conversion stages. Whereas if you used other topologies like AC coupled, it would go through the AC conversion stage onto your AC cables and into another product over here. It's more complex for wiring, and it's, as already said, it's less efficient. All of this is also monitored, so you can see all your information throughout the system in real time.
Okay, but I guess, Paul, that's a good analogy for, let's say, a residential homeowner. How does that work? Maybe if you have a business owner and the store's got a commercial customer, maybe an office block or maybe a convenience store, somebody owns a shop with different load needs, I guess. How does that? How can it help there?
Yes, good point. So we draw that example by just to simulate that commonly known issue of your peaks happening on either end of the PV curve. But in your general cases, I mean, in business cases, for example, you got loads going on throughout the day, so maybe it's not so applicable. However, the important thing to note is loads are extremely dynamic in the way that they're increasing, going high, low throughout the day. And if you take that example of your convenience store, you've got your fridges running throughout the day, and when your fridges have reached temperature, they're actually used very little load. They're doing very little. They're just satisfying the leakage of temperature. And when one of your customers opens that fridge, the temperature of that fridge will increase and the compressor will turn on and start consuming a lot of power. So when the temperature's reached and the door is closed, your power is very, very low. And then following the gray plot trace up here, when that door is opened, the compressor will turn on and use a lot of power. So as you can see, throughout the day, the fridge door will be open. And that's just one example. We opened many times and the loads will be constantly changing. And the special unique thing about the Solis hybrid is that it's got that meter there, which is extremely fast, that bespoke meter that's extremely fast and intelligent, and is constantly communicating to the inverter. And the inverter is also fast on the reacting to the commands and information sent by this meter. So it can satisfy and grab onto all that PV energy that might be leaked out. And it can also satisfy the non-leakage, leaked power by grabbing onto it and using the batteries to satisfy this.
Okay, that looks pretty good. And what about on a nighttime situation, and how can we help there?
Yes, so that I'm going to start initially with the first example where you've got your two peaks on the either end of the day. When you've got, in this example, you've got no energy coming from your solar panels, and you've got your loads going to both your critical circuits and non-critical circuits, and you at this time of this example, you're pulling the energy from the grid. And then again, the Solis meter being connected to the hybrid measures this import that you're paying for, and it knows to pull energy from the batteries. So this energy is the energy that you previously had put into the batteries from your excess solar generation. So you pull it out, and by pulling that out, you get rid of your import. So you're no longer paying for electricity. This also applies into your case of your convenience store. It would keep your fridges even running at low little base loads. It will keep your food fresh, all off PV energy that you generated during that day. So yeah, still applies in both cases. And again, this is all on monitoring.
Okay, pretty good. So probably getting the right system there, you're able to start balancing out those mismatches. That's what we can do here with the introduction of a hybrid solution. So I see it. The key thing is the meter, your bespoke algorithms, and how they react quickly to be able to bring down that misalignment and start maximizing the usage of the generation of the batteries, which I think is nice. Okay, so if that helps us with problem one, I think the next thing to look through would be how we can use this hybrid inverter to look at reliable energy supply, and hopefully starting to become more independent from the grid, not having to rely so heavily on the grid. So people are able to take control slightly of their own destiny, and how they can do that with this new solution from us. So Paul?
Yeah. Okay. So grid dependence is a big factor for everybody actually, but you would think initially mostly for your rural installs and rural customers where you in the countryside, and grid outages are something you experience on occasion. But also I must highlight that there is applications for this in your urban cities. I mean, if you take last year, for example, in London, there was a complete blackout. You also experience disruptions, normal day-to-day disruptions, roadworks outside your house that could take out a transmission line, flooding that could happen. All of those things can make your grid go down. Okay. And if in this case, looking at this image, your grid is online, everything's happy. You're watching TV, everyone's happy. And also with your convenience store, everything's online. And then if that grid is ever disrupted, so if there's roadworks or flooding, this goes offline. Everything in your house would go offline everything in your convenience store would go offline. You wouldn't be able to cash out. You wouldn't be able to do anything. Your security would all go down. With your Solis solution, this is where we come in. We creating an independence from the grid here, where you're splitting the circuits into critical circuits, the ones in orange, and your non-critical circuits. And the smart thing that the hybrid does is when the grid is there, it knows to put that all the grid power onto your critical circuits, as well as leaving it already on your non-critical circuits. So everything in your house is powered when the grid is there. Everything is powered. And then when the grid goes, like in here, the Solis hybrid inverter is very quickly able to detect that the grid has been lost. It opens up a set of switches inside the inverter, starts powering up the circuits from the batteries and the solar, and then the critical circuits are all online, and the grid is offline. And this is all happening
straight out of the box, Paul? I don't know, is that automatic?
Yeah, straight out of the box. That automatic changeover function is built inside that box, and this is all happening within 40 milliseconds from the get-go. That is so fast that if you're sitting there watching TV and the grid goes down, where previously it would shut down and you wouldn't be able to watch TV anymore, now you won't even know that the grid has been lost. The TV will continue to run. If you're working on your desktop computer here, this looks more like a laptop, but if this was a desktop computer, it would continue to run the desktop computer, and you wouldn't even lose your work.
So whereas no other equipment needed, though. That's just all built-in function.
Yes, completely built-in function. And to reiterate the speed there, your other applications like generators and other types of backup systems, you always watch those movies where they're in a hospital and they're like, no, let's just wait for the backup generator to turn on. And it takes a couple of seconds. Whereas this is 40 milliseconds in the blink of an eye. It's online, fully automatic, all inside the box.
Okay, but when that's happened, then am I still able to generate from my panels? Are my panels still running? Typically that would switch off. Am I still able to harvest the sun at that point?
Yeah. So very importantly, as you said, when the grid goes and the sun is shining, your PV generation suddenly stops, which is terrible. With your Solis hybrid solution, having your PV going directly into your Solis hybrid inverter, even if the grid is not there, it's able to utilize that solar generation and put it into the batteries and supply all the loads here. Effectively, what that's doing is lengthening the duration that your batteries will run.
Okay, and you've got a customer, a client who's wanting to either needs to be off grid or wants to maybe pull away from the grid a little bit, and again talking about independence, maybe not fully, but what about that in that situation? It's still applicable?
Yes. So off-grid systems are essentially backup systems with longer periods. You just got to make sure that your batteries can take you through to the next sunny period of generation. Generally, what I would suggest in those system designs, if you're going through a system design, is look for an annual period of load and generation and make sure that you design with the worst case scenario in mind.
Okay, and that's about balancing out the correct storage needed on site to see through, like you said. That's making sure you get that. I mean, I guess you can add batteries to the system, but it's about trying to find your balance point to cover everything off. Yeah.
Yeah.
Okay, very nice. So I'm thinking about my own house at home. I've got I have different on-peak and off-peak tariffs. So how does that interact with this hybrid inverter to try and make some gain there? Is there other ways to do that then?
Yeah. So there's two ways to do that on the hybrid. I'll talk about the first one first. It's time based. So in your example, you're getting if you're getting a cheaper electricity between 1 o'clock in the morning and 5 o'clock in the morning, you can program the inverter itself to force charge using the grid, the batteries, between 1 and 5. You just set the start time to 1 and then the end time to 5, and then it will do that. And then for the outside those periods, it will do its full automatic PV optimization function. Effectively, what you're doing with that whole function is getting off-peak electricity. You're getting peak electricity at the price of off-peak electricity. Really, really cool. You can, to extend onto that, you can also control the settings through digital devices, Modbus networks, and so forth. And that really brings, it's hugely powerful. It brings in the whole aspect and function of energy trading, where you trade your energy to your next door neighbor. And I feel like with transmission losses, again, that is a big factor to look at in the future.
Okay,
this also brings me into monitoring. So having Modbus networks and Modbus communications, all our products have the ability to be monitored online. You can look at your mobile phone of your farm if you're in your house, and vice versa, etc. And it's with the hybrid inverter, what changes is you get a 24-hour vision of your system. But you can also look at it in monthly, annually, etc. I just mean that you're also looking at it at nighttime and in the morning time before the sun has risen. With our PV inverters, it shuts down during those periods. What you gain is you can see your loads and exactly what your system's doing, where your energy is going, where you're grabbing that energy from. Is it from the solar generation? Is it from the grid? Is it from the batteries? You can see everything. And that's really useful for your customers. And they can draw reports. They can export it into Excel. Hugely powerful. They can show off a little bit. There's 4 network topologies that we support with our monitoring. We get our Wi-Fi and Ethernet for the wired connections, and then the RF link, the radio frequency links. That's to simplify the process of Wi-Fi communications, kind of thing. It's not Wi-Fi at all, but it's just to simplify the setup. And then your GPRS solution for rural areas where you just can't get those other 3 internet connections to. You put in a SIM card, pay some mobile data, and then get the system online communicating to the server. And then the final thing that this monitoring brings us is easy troubleshooting. It really makes it easy for me to get a vision of the system. You give me a call, and if you're interested in a question, you want to know where this energy is going, what's happening here, I can also just pop in there, have a look, see, and help you out. And then also, if you want to design a similar system in a similar area, you could grab onto another plant's information, provided it's your plant or you got access to it, obviously, but you can design other systems using the information you gather. But yeah, very, very powerful.
Okay, good. So I think if we look back at how the hybrid inverter is solving a few of those solutions, in summary, I guess you've got the smart Solis meter that's working with a bespoke algorithm to react quickly to try and align some of those mismatches. You've got out of the box automatic backup function, automatic switchover, which really allowing customers to utilize their system without stress, without any hassle. So that's a really nice feature. I think you're absolutely right. The tariffs will go from multi-tariff, we'll go from double tariff to multi-tariff shortly, I'm sure, and all sorts of bespoke tariffs coming through to allow these new storage systems to maximize them. And I think the fact everything's online, we're moving to a digital world. So the graph here shows how everything is connected, and I think you touched on Paul talking about where the future is, but grid trading. We've spent a lot of time already working with a few different grid trading platforms, and if we look to the future, the utility companies are going to, I'm sure, start looking at batches of residential and small commercial storage to trade with your neighbor, trade back to the grid, and really start to maximize the storage in your property, whether that's from your hybrid inverter storage, whether that's your car on the driveway. But I'm sure we will all be in a world where we all have more and more batteries around our house. And I think the good thing here, I'm happy to say we're already working on compatibility, but the fact everything is digital online, the world we all know today will go that way. I think if we take the solar industry as a sector, it's still, I say, infant in the world of storage versus what we've got deployed on a worldwide basis without storage. So the opportunities are massive. I think really what we're doing here, we're delivering the new 3-phase storage solution to Solis, hopefully Solis installers that are already happy and used to working with us today, providing cost-effective total system solutions, hopefully bringing down return on investment for homeowners, business owners, to really allow them to embrace solar storage as we all move forward in this next decade of storage and battery based solutions at home. So this new Solis hybrid is just coming out of certification for different markets now. We're expecting a reasonably wide launch across Europe in Q3, and it's really just a certification lead time on other territories. But certainly we'll see Germany, Poland, Italy, UK, Belgium come through in Europe first, with availability around the world to follow. So keep your eyes open, and if you've got any questions after this, feel free to fire them in. But I think from our side, thanks very much for listening, and I'll hand it back to you, Mark.
Well, thank you, guys. That was really interesting. Lots and lots of good questions that have come in as well. Much of this relates to the application side, which I guess we're not going to be able to delve too much into that, considering how much time we have left for a short Q&A. Just to remind people, the presentation will be available, as well as a copy of this, a recording of the webinar. You will get a notification from PV Tech regarding that's now available and links to it. So once again, thank you, Sandy. Thank you, Paul. I want to kick off, if you don't mind, with going back to the Solis smart meter. Perhaps you can just give Paul, perhaps, can give us just more of an overview again of what this actually does as part of the system. And I guess as well, people have realized with some of the questions that, you know, is this monitored by the intelligent meter? You know, is the intelligent meter monitoring things like phase sequence, frequency, voltage, all of that? So maybe just a recap on it's not just the 3-phase inverter here. There is actually another part to this with the smart meter. Thank you.
Yeah, so that the nice thing about that smart meter is that it's hugely intelligent, and it's probably the most important component in the whole system for the hybrid system. But in being so important, it is actually quite simple. It's measuring the grid values, the voltages, powers, phases, all of those things, and able to compute energies, powers, and so forth with that. And then the only job of it is to communicate that information through to the hybrid, so that the hybrid can make smart decisions from that information. So yeah, it is quite simple and very, very important though. Okay,
thanks for that. Perhaps another one here, Paul. The system comes with actually an integrated energy management system. What can you tell us about it in relation to the battery management side?
Yeah, okay, so the BMS, I often get folk on site getting confused with where the battery management system actually is. The battery management system is not inside the inverter, it's inside the batteries itself, and it is constantly monitoring the temperature of the cells and checking the status of all the cells and making decisions by itself. It could be thought of as the master of the system. It communicates to the inverter through CAN, and it tells the inverter, you can discharge me with 20 amps, you can discharge me with 50 amps, and then the inverter has to listen to that. So you could think of it as the masters of the system, whereas the inverter just listens.
Understood. Okay. There's been a lot of questions related to like these applications, or you know, in what scenarios. But one that's coming up quite a bit. Can the battery be charged from the grid in case the insulation is low? On the flip side of that, what happens when the grid goes down and then the grid comes back? How does this all operate? Maybe I'll try and answer those two. Just quick questions, because there's plenty of others that were here, like just asking details.
Okay, I'm not quite sure what you mean by the insulation is low.
Well, I think it's when basically the inverter would normally switch off at low light conditions.
Do they not mean low light conditions, low radiance?
Yeah.
If the batteries are empty and you're getting no solar generation.
Yeah.
So the one very important thing that the inverter has to do is keep those batteries safe and make sure that you don't damage the batteries in any way. There is protections inside the batteries to do that, so we work well together, that we all happy with each other. And if the state you set up, you select the batteries that you're using on the system. So for example, you select Pylon Tech, and it knows that it's using Pylon Tech, and then you set a bottom state of charge at which the inverter will take the batteries to and stop supplying the load. So if you designed your system correctly, you shouldn't really ever get to that state of charge. It will be able to float the state of charge, supply the loads, and keep the PV generation coming in and not getting to that level. But if that level is reached, unfortunately, the inverter is not. It can't just generate from nothing. It will have to shut down the system if there's nowhere it can grab that energy from. It will shut down. And then the other question was, how does it sync back to the grid? So that is extremely. It has to be done really, really fast. So the syncing of the grid is like phase. The phase of the grid voltages is important in that regard. So that is all happening locally on the hybrid itself. It's also got its current measurement devices and voltage measurement devices on the AC ports of the inverter. So it knows in microseconds those values. So it syncs up while it's off grid mode. So take, for example, you're in off grid mode and you're running with the batteries, and the inverter sees that the grid has come back. It can see the relays inside, which is a switch, are still open. So it can see the grid voltages, but still be running the off-grid system at a different voltage. It moves that voltage towards being in line, kind of, with the grid voltages that it now sees. And then once it's satisfied that the backup voltages, the critical circuit voltages, are equal to your grid voltages, it will close those relays and very little current will flow, and the system will run just like it was before the grid fell away.
Okay. I've got a quick one. I'm looking at the time, but there's a lot of good questions that are here. I'd like to try and get through one or two. These are just short answers. Does the battery port have its own DC-DC converter to match battery voltage to the maximum power point tracking?
The battery, no. So there's no maximum power point tracking with regards to batteries. You just grab the energy that you need from the battery. So there's just a DC to DC conversion stage inside the inverter, and no conversion stage on the batteries. It just allows you to pull that power, that power or not. There's only MPPT trackers on the solar inputs.
Okay. Yeah. Looking at the time, just one final question, guys, and I appreciate the flood of questions that we've had in. Someone's asking, so what exactly is the topology used for? Is it like a two-stage multi-level? What's the key things here?
Okay, I guess I'll take that one, Sandy. Don't worry.
Yeah, thanks.
So what I was talking about there is really the solar power is converted through a DC to DC conversion stage, and then it goes straight into the high voltage bus and then into the batteries. The batteries are sitting at a DC voltage, right? So it doesn't have to be converted to AC and then from AC to DC. the power that you get from your batteries are DC, and that's important to note. And whenever you go through the DC to AC conversion stage, there will be losses associated to it. So if you have solar power, it will go through one DC to DC conversion stage into a DC to AC conversion stage. It'll be on your AC circuits, which is external to the inverter, from your AC circuits into a separate product where you've got a rectifier that is controlled and will convert that AC back to DC. So it sounds like a round trip, which it is. It's gone from this to that to this to that. Whereas this topology that we use here is from your MPPT, from a DC to DC conversion stage into one more DC to DC conversion stage, and it's done. It's more efficient.
Great, Paul. Both guys, Sandy, Paul, thank you so much for your time today. I've really enjoyed this, and I can tell from the questions coming in, people have really got their heads around this and want more information. But thank you, everybody, for attending, and look forward to seeing you all again at another time. Thank you. Bye-bye.